And we're going to minimize this, zoom on this. All right, I'm gonna, okay, maximize this. And let's jump into it. All right, so welcome to week 12 of Summer of Shipping, which is a pretty crazy week because as far as we are scheduled, we have until next week. And so that means this is our second to last meeting for Thursday meetings. So that's kind of crazy. So last week we talked about unit testing, and I gave a presentation on some topics in unit testing that I thought were counterintuitive or really important for people to learn early in their career. So if you were to learn this in your internship, that would have been really good. But if you learned that at SOS, then I'd be thrilled as well. So this week, what we're going to do is we're going to have Sean visit us, where hopefully he's still getting his computer ready, and so we don't have him quite online. We might have to pause for a little bit as he gets going. But he's going to come by and he's going to give a little presentation on just his background as a ML engineer. So with that, we are going to do a little intro and talk about some of the initiatives that will be continuing on after this summer. And then, I mean, not after the summer, but after next week. So things will still continue, but we'll give a little update there. And then, of course, if you have demos for this week, we'll do them at the end, right after Q&A. So it'll be very similar to the time Slix came by and gave his presentation. We did some demos towards the end, but this time, because I don't think there's a hard cutoff for anybody, we'll try to do demos at the very end. So objectives, kind of a refresher for what we're trying to do. There's three. One, we want to help you get the interview. Another one is to pass the interview. And finally, job skills. Today, we're going to talk about machine learning, but sort of, not really. It's more as like, from a career perspective. So maybe not like how to use machine learning on the job, but more like how to choose machine learning as a potential career. So last Thursday meeting is next week. So if you haven't demoed yet and you want to demo in front of a big audience, it's probably going to be your last chance, on next Thursday. We're still going to have, hangouts and meetings and other opportunities to kind of just hang out. But in terms of the big organized thing, next week will be the big one. All right. So one of the things that will continue to go on after next Thursday is our study groups. And that's, it's cool because it just started. So yesterday we had our first study group meeting, and we were meant to kind of kick off designing data intensive applications. The idea is that we'll read maybe a chapter, maybe less a week, and we'll have people from all different levels welcome. So if you're a newbie or you're Martin Kleppman himself, you're all welcome to join the discussion. We had a few mentors as well, so it's great to kind of combine just all those different levels of experience to talk about. Newbies will be able to help other newbies understand more simple concepts, and mentors can also add that perspective of, hey, I worked on these systems and this is what I saw, to add some layers to that understanding. So it's going to be, I think, a really fun session, and the book itself is written in such a way that's approachable for lots of people, as well as going deep. And so it's a perfect book for such a wide range as well. So really excited. If you haven't joined us, it's totally okay. If you go to the Data Intensive channel in Discord, you actually see a recording and some notes that Tommy and Justin have for you guys. And so if you missed it, it's not a big deal. For example, if you are in a time zone that doesn't allow for meeting, you'll be able to stay in touch with the group by doing that. So very excited for how we're going to continue to kind of meet and study even into perhaps the school year. So SOS interview prep, this is another thing that will continue perhaps after next Thursday. We'll see how long it goes. I think a big one is contingent on Pedro's availability, and so we'll see exactly what happens when his job starts up. But essentially, we had our 5th meetup on Tuesday, and so a big shout out again, as always, to Pedro and John. Pedro presented this week on negotiation, to something that I wish that I knew about before I really started my job, and it was a lot about just like salary and negotiation and market rates, as well as there was some interview prep that I think the topic was heaps. I had to leave before that actually happened, but that was what was focused on this week. So if you weren't able to make it, try to come out. There's Tuesdays at the same time as this meeting, but they're on Tuesdays. So that's that. And then our demo list. So demo list is, one second, let me our demo list is going to, one second. Sorry, I'm getting a little bit distracted. Okay, so this was our demo list before last week. And then after last week, we were actually able to add a few people onto that list. So that was mostly actually Nico and myself who demoed, who are new to the list. And then we had Van and Samson also able to go. And so that is our demo list. And then I also put now a new column for teams. And so I know a lot of teams are kind of getting ready to, perfect, Sean is on his way. We are going to try to have as many teams as possible to demo and just share your work. So big shout out to everybody who's been demoing. I might have missed somebody or so, and we'll go from there. So that's our demo list. And so while we are waiting for Sean I just got a message from him. His meeting just finished, so this is perfect timing. He's going to give a presentation on life of a machine learning engineer. But before we do that, I'm going to give perhaps a very long and slow introduction as he fires up his computer of Sean. And he was going to come in here and be like, "Hey, I'm Sean. Sorry, I'm late or whatever." Well, I'm excited to see what he says as an excuse. But anyways, life of an ML engineer. So our guest today is Sean Campbell. Sean, actually, we went to school together. Not exactly in the same school. He went to Harvey Mudd. I went to Claremont McKenna. But if anybody's familiar with the Claremont Consortium, those schools are pretty much contiguous. They're almost touching, and so we shared courses and so on. But I actually didn't meet Sean until a little bit later. After school, Sean was a PhD candidate, and he studied for about a year on his PhD program. But then, as many a PhD student might be able to tell you, sometimes you get disillusioned from the program, and we can ask him more questions about that. But eventually, he started at Mixpanel, and after he was at Mixpanel for a while, he joined Google, and so that's where he's been. And Sean, I need to tell him the password. Should be in the link. 1 second. Okay, 1 second. So we're having a little bit of technical difficulties as we're trying to get Sean into the Zoom. I am going to go over to our messages, and you can see we are talking, we're trading messages. So I'm going to copy this password to him. Very, very secure.
Okay.
Hey, Sean, I think is that your
Looks
voice?
like I'm here.
Perfect.
All right, can everyone see me, hear me?
Hey, Sean. Hey, perfect timing. I was just giving a little intro just about your background, kind of dragging it out. And I was telling everybody that you were in a meeting that went a little bit over, and you were firing up your computer, and we just got you online. And so we just did a little introduction, but I'm actually gonna go back a couple of slides just to see, so Sean can kind of see what we're up to. Sean, one thing that we do, we meet every week, and this is kind of our little itinerary. We talk about our study groups. We're going to be studying the board book soon, this one. I'm pretty sure you're pretty familiar with it, or you've seen it at least. So we're going to have a study group that does that. That happens on Wednesdays. We also have interview prep on Tuesdays, and that might be something that you are interested in, maybe swinging by one day. And so that's what we did. And then we do demos as well. So we might do demos at the end of all of this. And with that, I'm going to finish this little introduction and then turn it over to you, Sean. So
okay, great.
Sean is now at Google, where, as my understanding, he works on this, but that's all I know, really. And so we will now go to Sean's presentation. And Sean, I'll stop sharing my screen. I can pull up your presentation if need be, but I'll let you share if you want to do that.
Let's see. Yeah, let me see if I can share. I've actually never used Zoom before. Is this sharing or not? Oh, there we go. Okay.
Excellent.
Okay, great. Yeah, thanks, Phil. It looks like you guys have been pretty busy. I'm pretty impressed. Yeah, I put this presentation together. My hope is that this will kind of get us started in thinking about like what a machine learning engineer does, what that means. It's kind of nebulous and really depends on the company and who you ask. but I guess I want to share my experiences, and as I'm going along, if you have any questions, feel free to ask them, and we can dive deeper, because this is really just kind of an overview, and I think there's quite a bit of depth to everything I kind of mentioned. Phil mentioned some of you are machine learning experts, and some of you aren't. So for those of you who are experts, forgive me. This is kind of basic, but at the simplest level, I think we should understand kind of what is machine learning. And machine learning, I think, is essentially you've got some data, you turn it into some numbers, and you try to predict something. So in the very simplest case, this could be a linear regression. You've got some points, and you fit a line to it, and using this line, you can predict points that maybe you haven't seen before. Maybe that's not very interesting, but it turns out, if you want to do something like image recognition, you could, if you really want to think about it, think of it as just regression on steroids. There's also unsupervised learning. So unsupervised learning would be something like, hey, I'm collecting all these data points about my users and how they're using my service. So let's say you're Netflix, and you see what videos someone watches typically and how long they watch them and whatever. Maybe you can kind of look at these kind of unlabeled points and start clustering your users and kind of figure out what kind of ways your users naturally group. So maybe the blue points would represent users who like romantic comedies, and red points would represent action movies, kind of people. Obviously, this is in 2 dimensions, and so you in reality you'd probably have multiple dimensions, and so you wouldn't be able to visualize it quite as nicely. And yeah, as mentioned before, you can do things like image classification. That's really useful for example, for like photo tagging, vision, robotics. There's all sorts of things I'm sure you guys can think of. This is kind of actually what I think kicked off the latest machine learning craze. So back in like 2010, 2011, we started getting really good results on these image competitions from neural networks. And so people started realizing we could use these for not only images, but everything else. And so that's kind of when this whole kind of neural network craze started. You also use it for speech. This is what I've been working on for the last couple of years at Google. So I work on a speech team. And so the goal is to take, there are multiple goals, but one of the goals is taking raw audio and transcribe it to text. We need to handle a bunch of different variations in noise, background, accents, different languages, and so it makes it very tricky to get it to work in all these different specialized cases. You can imagine that it's very easy to train like a speech recognizer that works well for very common words. But then when you switch to, say, medical dictation, it doesn't work so well. So there are a lot of interesting problems to be solved in this space. And then, of course, you've got to make these models fast and efficient. Recommendations, I think this is kind of a pretty canonical example that you'd think of. You don't recommend things to your users so you can make more money. So, Netflix or Amazon. Art, maybe some of you guys have seen, the Deep Dream or some of these AI-generated art things, where given maybe a source image, you can generate kind of an artistic representation. The neural network hallucinate, or maybe more recently, there's been GPT-3. GPT-3 is basically this neural network that can generate a bunch of text, and do kind of questions and answers and all sorts of really interesting things that make it seem more intelligent than it really is. I definitely caution you to avoid the hype here. While it's very cool engineering, I don't know that it's particularly useful at this point. There's certainly some use cases that are pretty cool, but be careful when kind of reading comments on the internet. So those were some nice pictures. Those are maybe some sexy applications of machine learning, but oftentimes, if you're hired as a machine learning engineer, you're gonna be working on one of this big list of problems. So it could be anything from search, finding relevant documents, or relevant queries, or autocomplete, detecting fraud. That's very important for payment systems, or well, I guess generally payment systems, but could also include like fraud. Predicting click-through rates. Trying to determine what kind of ads and what kind of posts and things are relevant to users. As mentioned before, you can maybe segment your customers. Maybe you collected kind of their usage patterns, and you can kind of learn something that's useful, and predict how much value a particular customer may bring to the organization. And then there's some like less known problems. For example, systems problems. Turns out you can do some really interesting stuff with databases. There's work where people will try to predict usage patterns on databases and then change, how caching and other things work. Obviously self-driving cars, anomaly detection. You can maybe set up a lot of metrics on your site or whatever service you're running, and you can automatically measure or look for kind of out of distribution activity, things that look anomalous, and maybe alert you if it looks particularly bad. So yeah, there's a lot of different stuff here. This is just kind of to get you thinking of what kinds of problems you might be able to solve, or at least make progress on with machine learning. It's really not a magic bullet, but anytime you've got a problem that you might be tempted to solve with kind of a hard-coded heuristic, it might be a good candidate for some machine learning. So yeah, at the end of the day, you can work on pretty much anything, but what you really want is you want to pick a problem that actually impacts the company you're working for, that moves some metric in a positive way that you care about, and you'd like to be able to quantify it. So as I kind of mentioned before, I don't think machine learning engineer is particularly well defined. It really depends on what company you're working for. It basically just means it will have something to do with machine learning, but it can span the gamut from you're sitting there basically doing research, you're writing a lot of models in Python, and you're just tuning hyperparameters and trying things out, to, hey, we've got a model, we need to make it faster, smaller, and scale it up to all of our users. And so you're building a lot of kind of infrastructure. So I think the majority of roles, from what I've seen, are kind of more in the middle. You might do some research and development, and then you go ahead, once you're pretty sure the model can do something useful, you'll build all the infrastructure that can launch it into production. So that's a bit of plumbing. It's a bit of you might be writing map reduce jobs and stuff. So there's a lot of variety there, and in fact, I think that's kind of where you might want to end up. I think when you specialize a little too much, it can get a little bit less interesting. But yeah, just kind of keep that in mind. So I kind of, last night I found a couple of job descriptions kind of to highlight this. So these are job descriptions for machine learning at Stripe and Twitter, and you can see that there are a lot of kind of random requirements, but it spans the gamut. It looks like you're not just going to be tweaking models, but for example, in Stripe, they're asking you to know like Kubernetes and Spark. And your Twitter specifically calls out that this is not a research position. This is not something where you're necessarily going to be, publishing papers and things. So yeah. So in terms of like my day-to-day and my experiences, so it's varied a lot. So I was previously at a startup called Mixpanel, and when I was at Mixpanel, I was working on anomaly detection. And so Mixpanel is a startup that takes in basically implements analytics for different sites and apps. And so customers send us these time series, and we thought it'd be nice to set some automated alerts. So if a customer's time series look bad, maybe we send them a notification. And so a lot of the work there was just building the infrastructure to support that. So you can imagine we've got this big database of customers and time series, and so you have to build something that schedules these different time series and then models them. And then if they look bad, you need to figure out a threshold at which you send a notification. Then you maybe want to rate limit the notifications. So there's a lot of kind of design work, product work, and just regular old engineering, I'd say, for that first role. Now for my role at Google, I've switched more over to, I'd say, kind of researchy related stuff. So we've got these big, well, there are a lot of models within the speech team, but it runs the gamut from just creating these small hot word models. These are models that detect, hey, you said okay Google. Now that we've determined that you said okay Google, let's run some other models like speech recognition. So it runs the gamut from these simple models to really complex models like the full recognition pipeline that turns your speech into text. And my day-to-day there has been a lot of we need to collect data, and so we've got this pipeline of contractors that will record potentially, data for us depending on what we're trying to do, and we need to get this labeled depending on what the task is. And then sometimes there's, the people labeling the data don't understand the instructions, and so you have to go back and relabel the data. Or maybe I guess for Google, we don't have to worry, or for speech, we don't really worry about data freshness, but this could be something that happens for an online pipeline, where your data goes out of date quickly. But yeah, so a lot of the kind of this data munging stuff, you're writing these pipelines, you're collecting the data, you're analyzing, make sure it's reasonable and works well. And then you're trying to improve the models. So improving the models might be, hey, we've got this new data, let's retrain the model, let's tweak some parameters. Or it might be, hey, I've got these new ideas for these new features that I want to add in. So right now we're just using, say, the raw audio waveform, but maybe we've got some other features that we could feed into our model, and it'll improve the performance. And so you end up doing a lot of that. And then, of course, you want to make sure that your models are actually doing well in production. So implementing like monitoring in the form of like dashboards, so you can see how your model is doing on like real production traffic, is really important. You may train a model, it does well on kind of your offline test sets, but maybe in production it's different than what you've trained on, and so there's a mismatch, and you should be aware of that. I guess the final point is, typically there's not a lot of math. You should be aware of the math underlying whatever models you're using or building, but quite a bit of the time, the models are already built, or even if they're not already built, you'll end up using, you can read some papers, read what other people are doing, and pretty quickly figure out what, tools you should use. And so at the end of the day, machine learning is kind of just another skill that you can have in your toolbox. Yeah. So I keep on talking about neural networks, but there's a lot more to machine learning than that. Neural networks are the latest craze over the last maybe decade, but there are a lot of other techniques that you can use that can be just as effective, or if not more effective. And so I don't necessarily expect you guys to know what all these are. If you do, that's great. But there are other methods out there that can get you really good results on your problems. And part of being I guess a good machine learning engineer is kind of knowing which techniques to think about applying and then test out, and iterating on. So on top of that, there are definitely privacy considerations, and so we're seeing this a lot today. So there's this trade-off where it's like, to build these good products, you do need some sort of data. Now the question is, how do we collect data in an ethical, non-privacy violating way? And so there's a lot of work and a lot of discussion about this. And so there are ideas like, hey, federated learning. Maybe we can, instead of taking data off a device, maybe we can keep all of your data on your own device, and we'll train models there, and it'll be personalized to you. And so there's no question about loss of privacy or something like this. Or maybe we don't allow any sort of training on user data, and we have to kind of pay people. There's a lot of stuff you have to think about.
Sean, I think we just lost you for a second.
We get these great results on academic data sets. Where should I go back to?
I think just when you're talking about GDPR.
Oh yeah, so we can discuss this more in maybe the Q&A, but yeah, for GDPR, we're getting more intense, more strict privacy regulations, and so making sure that you can still train good models and respect people's privacy is something that every big company is definitely thinking about these days. And then yeah, the final thing is bias. If you collect a data set and it doesn't, there's some famous examples of this. For example, for like image classification, if you train your model all on, say, light-skinned people, and then it's never seen darker-skinned people, your model may make much worse predictions for anyone who's not white. So these are things you want to think about, be aware of, and try to validate if possible. This is maybe the simplest kind of outline of what a machine learning project might look like. It can vary a bit depending on what the problem is, but generally, you find some kind of business problem that, or maybe someone finds it for you, that you think you can have an impact on. So for example, at Mixpanel, this was, hey, we think we can provide value to our customers by alerting them when their time series look wrong. They look anomalous. And so, maybe you want to create some metrics where we look at, say, how much we want to figure out how much our models help our users. So, in this case, it could be we actually just do something simple, like we send out surveys asking our customers some series of questions to figure out, how many of these alerts were useful. For other applications, such as, say, click-through rate, it's pretty obvious. You can look at the predicted click-through rate versus, what actually happened. So there should be some metrics that you're looking to improve, and you should be able to check them after you build your model. So now you need to get your data to train the models. And so this is going to be a lot of like hooking up to databases, writing pipelines. So pipelines might include Hadoop or Spark pipelines. They're kind of like MapReduce or whatever. So there's going to be like a lot of munging where you pull data from different sources into a format that you can use to train your model. You're then going to have to go through your data and figure out, hey, does it look wrong? Maybe people use different formats for the dates, or maybe the encoding of a particular feature is different, depending on which source you pulled it from. So you need to go through your data and make sure it's all consistent and looks okay, and then maybe get it labeled. And then you might train like a V0 model on that. And if it does well on your offline data, you might consider launching it. And so if you go ahead and launch it, you basically end up in this kind of cycle of you launch, you look at the metrics, you tweak the model, collect more data, get feedback, relaunch, continue, forever. I guess something to note is, depending on what the problem is, you may actually set up a pipeline where your model automatically retrains on new data as it comes in. So I linked to something in the resources later where I talk about, or where Twitter talks about how they make predictions for their timelines, and they've got a system set up where they retrain their model every other day on the newest data coming in. So yeah, this can definitely vary a bit. Yeah, there's a lot of hype about machine learning these days, so I definitely caution you to not read too much into it. I think machine learning is a very useful tool, but it's seriously flawed and seriously limited in a lot of cases. Oftentimes, particularly for neural networks, we don't know why they're making the predictions they're making. You can fool neural networks with clever little examples, and oftentimes neural networks can be very confident about their outputs, despite being completely wrong. And so, maybe you train your model on everyone with English accents, and then you try to evaluate on people with American accents, and your model will be very confident, but it'll just do very poorly because your domain has shifted. And that's just generally true. They don't generalize as much as we'd like, and they aren't very introspectable. And because of that, they're not great for safety critical applications. And part of that you can kind of see with self-driving cars. Now, of course, self-driving cars have a lot of different parts in them, but with self-driving cars, part of the reason maybe why we don't see them fully launched is because getting all the models to work 99.99% of the time is very difficult. And then knowing that, being able to prove that is very hard. And then, yeah, as mentioned before, if you look at academic papers, you'll oftentimes see these great results in these academic data sets. And you might come away from reading a paper and think, hey, it looks like we've solved speech recognition because we've gotten really good results on people reading, books. We can recognize that. But what these papers oftentimes leave out is their models don't necessarily do very well on, real world data, which is got a lot more noise and a lot more variation in like speaking or speaking rate, accents, volume, etc. And then, yeah, I think Phil kind of mentioned this. My journey, I did a year at grad school in machine learning. Decided I didn't want to do research. I found it a little on the depressing side. And then I worked at Mixpanel for a couple of years, and then I've been working at Google for the last 2 years on speech. So at this point, I definitely enjoy machine learning quite a bit, and I'm very optimistic about its future, but definitely very cynical and wary of the hype. Yeah, and in terms of getting into it, I don't think you necessarily need to be you need any particular special qualifications. If you want to get into some very deep research group like Google DeepMind, yeah, you probably need a PhD or some impressive background in some way. But in general, really, you just need to be a good engineer and have an interest in it, I think. And so if you know the basics, which you can pick up from online courses and reading blogs, and I have some stuff listed in a later slide. You can definitely break into it. It's mostly just asking asking people if you can help them out. When I joined Google, I didn't have any experience with doing machine learning for speech, and I basically just asked, and they let me work on it. So yeah, here are a few resources that might help you if you're at all interested and you don't know anything about machine learning. Particularly like Michael Nielsen's kind of intro to deep learning. He doesn't dumb it down too much, but it's also very well written. And then obviously you can find things like Coursera. NeurIPS is where all the latest and greatest machine learning papers tend to go. And then reading company blogs, I think, is incredibly useful. So you can look at Google and AI or Google and Facebook AI blogs, and those tend to be very research focused. So if you're interested in that side of things, you can kind of keep up to date by looking at those. But if you're more interested in kind of the engineering behind some of these systems, you can look at things like Twitter's blog, or like I think Discord actually had some interesting things. The resources are out there if you're willing to look. So yeah, I think that's all I've got actually.
Awesome.
So if I hope this clarifies something, and I'm happy to take questions.
Totally. Also, while we're at it, I want to take a moment. Hey, let's give Sean a round of applause, and thank you for telling us about just like all of what you do and machine learning and kind of your background and all the stuff that goes into it. And I'm sure people will have more questions, just get a little bit more detail. But I want to take a moment also to introduce a friend of ours, Min, who's also online, and he just joined and he's been commenting and kind of joking. And one of the things. So Min is actually also, Min, you work on machine learning as well, but for very different, or maybe not that different, also in the language space, I would say, yeah. And
yeah,
and I'll let you introduce
yes.
yourself. And I don't know if Vijay is also present, but
wait, I think he's here, but the machine learning program actually has actually blurred him out, so I need to turn off this.
Okay, so the machine learning is just faulty, and you can't see. Oh, there he is. Okay, if
you can't see him.
Okay, so Min and Vijay, if you guys
okay, wait, I need to turn on this thing.
Yeah, if the two of you could introduce yourselves as well, and then we can they'll participate in the Q&A for everybody, and so we can ask all of them questions. So there's Vijay right next to Min, and they're actually roommates, and so we will hey, if Vijay and Min, if you guys can do a quick introduction, and then we'll open it up to general Q&A for people.
Yeah, yes. So basically, I used to actually live with Phil and Sean as well in the same house.
Yeah,
believe
we
it or
were
not.
all roommates at one point.
Yeah. Yes. So yeah, so I used to work for Box.com, which is a cloud storage company with Vijay, and then I think we got more of internet infrastructure and cloud storage, so we moved to a smaller startup to do machine learning in natural language processing, and then we got acquired by Cisco. So now we are working with Cisco to build and deploy different conversational AI solutions for Cisco use cases.
Yeah, so my name is Vijay. I think looking at what Sean's slides were, I also did like undergrad in CS, and then moved to Box. Then went to a smaller startup called 20N of just 6 people. And then that startup kind of failed. So I moved to MindMeld, and then MindMeld was acquired by Cisco. In the meantime, I was also doing a grad degree for data analytics as well. And currently, as what Min mentioned, we are working on conversational AI applications. So this is mostly to do with chat as well as voice assistance for Cisco. And as part of that, working on open source frameworks that can help with building great conversational applications.
Yeah, especially at Cisco, we take data very, very, very seriously. You know, we don't see any customer data. We don't save any customer data, unlike some other company that we know. You know, not sure which one is that, but other companies. Just to say that.
No need to throw shade between the three of us at the moment. That's that's for.
Oh, by the way, also he forgot to mention, but he's also another proud alumni of. Oh, by the way, also I forgot to mention he Mud.
Yeah. Vijay and Sean were classmates in school. So yeah, so let's open it up for any questions. If anybody has anything that they want to ask people, maybe what it's like to, maybe you want to get perspective from Min and Vijay on what their work is like, something along those lines, and we'll go from there. I have a couple of questions, but I'll first open it up.
So actually, I have a question first. Is the audio quality okay? Can you guys hear us?
Yeah, I so far it's been pretty solid. Maybe a little bit of distortion, but mostly pretty good.
Okay, sounds good. Yeah.
Cool. All right, so we've got our first question, and the first question is, what % of your time is spent between gathering data, cleaning data, researching, and implementing models? So this comes from Andrew, and maybe we can start with Sean, and then we'll go to Vijay and Min.
Yeah, so I guess.
It's a funny question. So,
hey,
Sean,
a bit.
you actually just cut off for me, at least. If you could repeat.
Oh, yeah. So okay. So at Google, a lot of the pipelines are already built in terms of collecting the data, and so it's more about ensuring that the data quality is there. And so I would say at Google, I spent probably more like 30% of time experimenting. Running experiments and doing kind of researchy things. I'd say another maybe like 50% is kind of infrastructure stuff where you're trying to clean up production code or rewrite some training code or just general kind of code maintenance, general engineering kind of work. At Mixpanel, I'd say I'd call out and say that part of collecting data is also just building the pipelines. And so yeah, I'd say it's more like a 90-10 split. You're building these pipelines and then analyzing the data, and then you spend a little bit of time experimenting with the models, but frankly that's kind of the easiest part.
Awesome. And then let's go to Min and Vijay.
Yeah, so I guess I can speak first since I have the headphones. So essentially, it really depends on what type of work that you're doing. So for examples, right, and I think Sean kind of touched on it, but I think he didn't really elaborate much on it. Essentially, machine learning is like a big umbrella for a lot of roles. And if you really want to formally separate them, there is the machine learning scientist who study this model. There's the machine learning infrastructure engineer who build the pipeline that build this model and save the data and clean the data. And then you have the data scientists who spend a lot of time collecting and looking at data and doing experiment and trying to figure out what kind of insight we can get from this data. And then you have the your regular back-end engineer who also work in machine learning, but that guy probably just trying to build features on already collected data and maybe add some data to fix a particular issue, for example. So it really depends on the roles. You can spend like, I don't know, maybe 100% your time with your data, or maybe for me, for example, on my regular day, I'm working on the So I work on the platform side of things where I build conversational AI platform to allow other people to build the application. So I don't actually spend much time looking at the data. Maybe I should spend more time, but that is what I'm working on these days.
Yeah, in terms of how Cisco does it, we have a data quality team that looks at the raw data and basically, makes a list of priorities that the ML team should look at. So this would be if the model is incorrectly predicting certain types of queries, those get flagged up. And this is all done by a data quality team. And so once those issues are flagged, we create tickets for them. And then the tickets are either handled by our, I would say more of a full stack engineer who handles both, if the issue is, a small issue where you just need to add a few more queries to your model in order to learn, in order to actually understand those kinds of queries, it can be done easily. But for issues that are a bit more complex, the machine learning team can take it on and either build new features for the models so that they can generalize well to those kinds of queries, or build other sorts of machine learning techniques that can generalize the problem. So I think in general, as a machine learning engineer, a good thing to spot is how to generalize like a solution to a problem. So even though your error or bug could be very specific, like it's not understanding, for example, an insult, a particular insult. So when someone says something like "you're very bad" or something like that, it might not be able to understand that one query. But how do you generalize that for an entire class of problems? I think that's where it's sort of like similar to programming practice. You always want to find a more general abstraction. Similarly, you could extend that to machine learning engineering, where you're trying to find how you can build systems that can generalize well to a class of problems rather than just fix, one simple issue.
Sweet. I think there's a question that just came in, and I think it goes well with just kind of some things that we've been talking about. And so it's more just on neural networks. And I think Sean mentioned a little bit about the different types of machine learning techniques that are used in industry. And so I was just wondering if you guys could talk about first, neural networks. If one of you could give a quick, like 5-minute or 2-minute like description of neural networks at a very high level, how people should think about it if they're very new to the concept, and which techniques are useful for what, and what do you guys use? So if you guys can kind of just answer that question. I don't know who wants to kind of describe neural networks first, but maybe I'll ask Sean to do that, and Min and Vijay, you can add on a little bit, and then if you guys can talk about the different techniques and what kind of works well in your experience.
Yeah, that's a tough question. So I think for a lot of machine learning roles, they end up getting really, really specific. So if you're working on, say, speech, you end up learning a very specific set of neural network techniques these days. And there's other stuff as well. Same thing, a different set of techniques. Maybe they overlap some with speech, and then like vision, you become an expert in a very specific set of like convolutional neural networks. And so these things differ.
So we just
there
lost
may be some general principles that I'm really good at speech.
We lost you. Differ is the last thing we heard.
Okay. Yeah. In any case, the point is you end up specializing a lot for some of these very niche domains. For other domains, oftentimes there is kind of a standard, pretty simple approach. They're pretty standard things. For example, you might run logistic regression. You might run linear regression. You might avoid the neural networks altogether. You might use, like a naive Bayes model. And so in terms of picking which technique to use, a lot of times it's like going and reading the papers and seeing what people are using these days, and then trying to figure out if those techniques seem like they'll apply to your data set. Or maybe you just try it out and find out if they do. As far as like what is a neural network, I think I would describe it as basically just linear regression on steroids. You take linear regression, you change it a little bit, you run it again, kind of on its own outputs. You do this a bunch of times, you get a neural network. It's not quite right, but at the end of the day, yeah, you're taking some set of numbers, maybe the pixels in an image, and then you're trying to learn a set of weights that basically transform those until you finally get to a single, or some set of outputs. Yeah, I don't know how to explain that simpler without some diagrams or something. What else was there to the question?
That was the main part. It just kind
Okay.
of like what kind of techniques work for different types of problems, and kind of you could explain kind of a neural network. And so I guess we'll turn it over to Min and Vijay. If you guys could maybe add on to that answer, or just kind of add your own experiences.
Yeah, sure. I guess I can talk a bit more about neural network, and I think Sean is more on the pessimistic camp, and I think he
Man, Min, you're throwing so much shade at me today.
But,
Jesus, man.
But he's right. Like, I haven't seen you in a long time, so I will stop throwing shade. All right. Okay. So anyway, yeah, I think that we have been working on neural network for a while, and I can speak of neural network for a while. I think about neural network, right? So first of all, the inspiration comes from the modeling of the human brain. I mean, I think that at this stage, a lot of neuroscientists probably don't think that the human brain is actually like a neural network that we build in computer science, but the inspiration is there. And one of the reasons why it actually worked out so well in the past, I don't know, maybe 6-8 years, is that the mathematical technique are similar than a lot of other things that we have done in the realm of engineering. So the equations are mostly linear in a lot of places. That's why they can actually build this parallel hardware and compute infrastructure to process the data, and then based on this data, then they can actually improve the accuracy and the performance of this neural network. And what is extraordinary about these network, unless when the people first invented them, is that it seems to offer almost linear increases in performance when you increase the amount of data. And that's why you have seen like a huge competition for who get more data to fit into more neural network. Of course, I think that now we're hitting the limit of it, both from the consumer perspective in terms of privacy, as well as from some of the theoretical perspective. So, but even though, like I think Sean mentioned GPT-3 as one of the big language model, and it's huge. I think it's one of the biggest language model that people have ever built. And from one of the paper that we were talking about in terms of GPT-3, it's still hint that you can increase the performance of the model even more if you just simply add more data. So I think now it's just a matter of people trying to understand more on the nature of what actually constitutes intelligence. Is it the ability to just, I give you a sentence and then you can add more word to a sentence to make it sounds meaningful, or actually to understand the meaning of these sentences and then do something with it. So I think now they are actually having a lot of discussion about it. But in terms of the fundamental research, I still say that it's a very fascinating field. Some of the top of the line model that we see in the last 3 to 4 years actually have replaced something else came out like 2 years ago. So, and the other thing about neural network that make it really extraordinary is that somehow you can apply the research in one field like speech, and then you can somehow use it. That's kind of similar architecture, but try and apply it into computer vision, and it kind of works. And you can use something from computer vision and you can modify it a little bit and put it to speech, and it kind of works. And that's why there are so much cross-field interaction in neural networks. So it's very different than, let's say, you build a particular classical machine learning algorithm for vision, and that would probably not apply to speech. But I think in terms of neural network, there is a good chance that it could be applied across different domains. So that's why people are so interested in studying neural network.
Second portion of that question is kind of just like what have you guys seen in the past? And I think I might have cut off Vijay. So Vijay, if you want to add some more thoughts before kind of talking about like what kind of models kind of work in your domain, feel free to do that. But I was just going to kind of nudge you guys back to that part of the question.
Yeah, I think one paradigm that I think is important that I've learned from being in this field for some time is that instead of thinking about the models, I think you need to think more about the problem that you're trying to solve, and also in terms of like okay, I guess what I'm trying to say is that you have to think about what your inputs are, your distribution of your data, and what is the specific value that you're trying to solve for your application. And the reason why I say this is because a lot of the times as machine learning practitioners, you get really fixated with a particular model and you really want to get that to work for a particular problem. But I think instead of thinking about it from what is the best model, I think you need to think about it as like these machine learning models are just primitives that you apply, and you're getting some sort of like answer from that, right? So in this case, you will get a different prediction from a logistic regression model versus an RNN versus a CNN or whatever. But these are just primitives that you're using. And by primitives, what I mean is that you're adding supervision to a problem and you're getting an answer. But these are just answers that the model provides you. They're nothing more than that. So a lot of the times what happens is that people get really involved in like making the model better or trying to like change nitty-gritties to the model, and they really get involved in model development. Versus I think what I've noticed is that instead of really going deep into the model, is to take a bigger picture and see and try out different models like logistic regression, CNNs, RNNs, and just look at the bigger picture and see what models are performing differently as compared to another model for your data. And by that, you can get some interesting quirks in terms of what your distribution of your data is and what the models are trying to actually do with that data. And then from there, you can try and solve your bigger problem, either by using an ensemble or by asking a different question to your stakeholder, being like, what exactly do you want this product to actually do? And then go back to figuring it out. Because a lot of times you just get really bogged down with the model itself versus trying to like add value to your product.
Totally.
Yeah, and I guess I would add on to that. This kind of also touches on the difference between your model running in production versus your model's performance on a test set. Improving your model 2% on an offline test set may not actually mean improving your model in production, because your test set may be older, the data may have shifted, it may not be fully representative of it, or maybe frankly 2% improvement of your model doesn't actually help your business. So it's something to think about. It kind of depends on what problem you're solving, and that determines how valuable these improvements are.
Yeah. Hey, one quick question for Vijay. Could you explain what an ensemble is? That's a word that I didn't understand. It sounded like it was a pretty common thing. So I wanted to see if that was a term that is a common in the industry, or and what that really means.
Sure. So like an ensemble is when you have sort of decisions from multiple models feed into a policy model that then predicts based on those inputs from the previous decisions to make one decision. So essentially, it's like a the simplest model ensemble would be like a voting system, right? Like that you say that of them said yes and one said no. So I'm going to say yes to the output, the final output, because I'm just going to pick the most number of votes. But then there are different other types of voting schemes that you can use to like produce your final result. And in general, what they have shown is that ensemble models are better, provide better accuracies than the submodels themselves. So generally, there's some sort of ensembling that happens, at least for production systems. Even though it might, there's trade-offs, obviously, there's latency trade-offs, there's maintainability trade-offs, but ensembles in general do better than just focusing on one model.
Gotcha.
And another thing which I find really useful is this concept of, there's a paper that came out called Snorkel, where Snorkel is a way of basically trying to iteratively make your model better based on the underlying data, where with Snorkel, what happens is that as you feed in more data, as your model predicts on it, you can take the predictions that it's not very confident on and put that through a human in the loop and get back a correct prediction and then feed that back into your model. The concept itself is called active learning, but what we have found is that active learning provides the model with much better information. So again, we want to prevent situations where you have garbage in to your model and then it just produces garbage out. We want to prevent that and only feed in the model data that is new and unique so that it can then make better generalizations from it. So with techniques like Snorkel, you could provide data that is the model is currently unsure about, annotated in a way that it's correct, and then feed that back into your model, and your model is much better. So we have found that even 45% of the data is so. What we found is that instead of feeding in 100% of the data, you can feed in only 45% of the data and still produce the same accuracies as 100% of the data. And the reason for that is because that 45% has all the information that is needed, versus the other 55% is just like sort of repeats, like things that the model is just memorizing based on previous patterns. So that's something again to look at the data more rather than looking at the model itself.
Gotcha. One kind of follow-up that is along this theme of kind of thinking about, I think the three of you guys are kind of trying to reinforce the importance of, hey, oftentimes as a practitioner, you are operating in a business and you need to think about the business as well as just how much it moves the needle. One of the questions that we have here is, do you actually ever have difficulties explaining results to business people? And does it vary by model? Maybe they can understand, for example, a linear regression very well, but the moment that you do anything else, they begin to they start like getting very confused. And so just that relationship between business people and results from a model. Can you guys talk about just kind of how that works?
I guess I can go first. I personally haven't had a lot of difficulty with that, but perhaps I haven't been presenting to the right people. Typically, the people I've interacted with have had at least enough understanding that a lot of these models are black boxes, and that trying to understand them is maybe it's not futile, but it's very difficult. That said, for something simpler like a linear regression or a logistic regression, sometimes people are confused and make these erroneous assumptions. Like, for example, having a higher weight for a particular feature means that feature is more important. That's not necessarily the case. But yeah.
Oh, looks like we just lost Sean. Hey, Sean, I think we just lost you. Let's go to Min and Vijay while we see if we can get Sean back online to finish up that thought.
Yeah, so I think I can talk a bit more about the business side of things, since we actually also have a lot of experience with explaining machine learning and natural language processing concept to a variety of people. So I think that maybe around 2016, 2017, when machine learning, deep learning technique just came out on the scene in a very public way. So I think there was a lot of people who didn't really know what it is, and one of the main challenge is to explain to them, to educate our business leader as well as salespeople, like almost anybody who come into this thing, like what it is, what are its capabilities, and what are the implications for businesses in the short term as well as long term. And I think now that we actually are here in 2020, I think people have a fairly decent understanding of some of the basic concept of deep learning, neural network. Why is it important? What are some of the things that they can do in terms of infrastructure to build these machine learning system? Now, even so, I think in 2020, what we're looking at is that sometimes for business leaders, they still don't have as much hand-on experience with machine learning, and in many organizations they don't have the right type of expertise to actually think like conceptually how much manpower, how much data does it need to actually build a feature. Like let's take an example of, suppose that you are Skype and some other chat application, and you want to build, you see that Microsoft come out with background blurring and Zoom has background substitution. And so you want to build a similar feature for your product, but then you don't know like how much time and effort will it take and what is that exact competitive advantage. How much of that does the customer need? Because does customer need background blurring? I don't know, maybe. How much I really want it? And if you don't have it, what is the long-term implication? It's a different type of question than, say, video or audio quality. So that is pretty much clear, right? And so that is still a hard thing for a lot of people to grapple with. And so that's why a lot of companies are still kind of on the fence at the moment about incorporating some of the smart feature into the product. But I think that if we talk about from a consumer product feature perspective, like I think over the long term there will be pressure for more and more companies to adopt this smart feature, right? So companies will tend to go into two directions. They either buy some off-the-shelf component and trying to make it work for their existing solution without investing too much into core competencies. Or B, they will actually try to play the long game and try to hire people and build a team internally within their own organization. So I think it really depends on the exact circumstances and context that a particular organization want to do A or B. But right now, for a lot of business executives, a little bit of trouble trying to grapple with how do I get that smart feature from Microsoft and Google to work in my particular product, and how much time, energy, effort it takes to do it, so on and so forth. So I would say that building a machine learning feature is something a little bit non-trivial. You need to have the right type of people.
Yeah, that's an understatement, to say the least. Yeah, and Vijay, do you want to add anything onto that? Just like interacting with business people and how they understand and interpret models.
Yeah, I think I think both Min and Sean mentioned is that like I think most of my interactions are with mostly highly technical people. So I'm going to talk about what we currently do. So there are common metrics, like at least for natural language understanding, there's F1, precision recall. Those are the kinds of metrics that pretty much everyone needs to understand in the business in order to build and develop these models. But apart from that, just talking about aggregated stats, there's also non-aggregated stats. So things like win-loss. So with win-loss, what happens is that you want to see whether your model is regressing on what the previous model is, and what types of queries is it actually doing better at. So that's another metric, which is trying to see, what ratio of previously correct queries is it incorrectly predicting right now, and what's the ratio where it's correctly predicting incorrect predictions from the last model. So that's another thing to report, so that you can actually, everyone can understand exactly what the model is actually doing. And I think we have found that to be very useful, apart from these aggregated stats, to understand whether it's an actual improvement or is it, just doing something weird.
Sweet. Yeah, and also let's go back to Sean for a moment. I think Sean, right before you cut off, you were mentioning some things that people like misunderstand about potentially. You're saying like, okay, if a linear regression feature has maybe a high weight, it's not necessarily the most important. I think that's at the moment you cut off. I don't know if that helps you pick up again on your thought, or if you want to finish that thought up, or if that's kind of like fleeting and no longer with you. Oh, you're on mute. Here, let me unmute you.
All right, there we go. Wi-Fi and self-muting. This is a bad day. Yeah, so I would agree with Vijay. Most people I interact with are pretty technical. They more or less understand the big picture, and it's not a big deal. But I have had some discussions where it's like, hey, should we expose, or should we try to rank features based on their weights, and having a long discussion there. And we came to the kind of conclusion, the correct conclusion that there's some risk there where if you try to rank features, you're going to do it completely wrong because the weights don't necessarily mean anything. but yeah, I'd say it's not really a big problem that I've encountered in terms of dealing with non-technical people.
Cool. Alrighty. The next question that is kind of up on the list. I think, yeah, I'm going to ask this question, and if you guys have anything to add, you can do that right before answering this question. But the next question is just about interviews, and what does it look like for a machine learning engineer to be like kind of interviewed or conduct an interview if you guys have to, when you're hiring people to join your teams, what do you guys look for? So on either side of the equation, if you guys can just chime in on what that kind of looks like for machine learning engineers.
Okay, I guess I can start. My experience with the machine learning interviews. So when I've had to do them, typically there's a couple of like basic math questions, maybe something to do with vectors or probability, and then usually there's a machine learning design question where you're asked to design something like an anti-spam feature or detect trolling or some moderation or some sort of standard feature that you might find on like say Twitter or like Wikipedia or whatever. And so in those cases, I think it really depends on what the emphasis of the position is. If the emphasis of the position is more research based, they might ask you more questions about the specific like model architecture and whatever the state of the art is there. Whereas if it's more of a generalist kind of machine learning engineer role, it's probably going to be more closely related to kind of a standard design interview that you'd get as a software engineer. So you're building pipelines and you're collecting data, you're implementing metrics. So yeah, I think it varies, but in general, you should tailor your preparation to the role.
Yeah, Min, Vijay, anything to add to Sean's answer about what those machine learning interviews can look like?
Yeah, I think it's pretty much what Sean said, right? You have to understand first what role that they're looking for, and in that role, what are the exact responsibility. And so because the term machine learning engineer is a little bit nebulous, it can encompass the whole gamut, right? So someone who actually is a research machine learning engineer at, let's say, OpenAI, for example, you can expect this person to be highly competent in basically understanding this model architecture really well. And so you basically, for these people, you need to test that, okay, do you know convolutional neural network? Can you implement on a spot? So on and so forth. What are the features that you, what are the way that you train hyperparameter tuning? And so what are the hyperparameters for this model? What are different algorithms that you can use? What are the loss function? So things like that, it's just kind of roll off the tongue. And so being able to answer this question highly technical really well is probably a requirement for very specialized roles. For somebody who work in like a more cross stack, so basically you want to be able to ask this person, okay, how do you collect data? If you have an unknown question, problem, how do you start thinking about collecting data? How do you clean the data? And then how do you build your very first model? And how do you get something just right off the bat and working? So a lot of time when we interview people who are machine learning graduate, one of the things that we notice is that they are a lot of people are very excited about deep learning and really large model. But I think that realistically speaking, in the number of companies that actually can apply this really large deep learning model is actually pretty small. Like, I think if you really count it, they're probably countable at the moment on like your finger. There are probably 10 companies who actually really excel in that kind of thing. And the rest is just like maybe use something off the shelf and so on and so forth. And so being able to understand these also, apart from deep learning model, like the classical model, like clustering algorithm, k-nearest neighbors, logistic regression, linear regression, to understand this pretty well and have some kind of working knowledge with them is probably very useful. And so it really depends. And of course, sometimes we don't really ask our application like the exact thing that we are working on, because it's unfair to ask people something that you have a lot of insight about. And then expect you to come up with this insight like on the spot. So sometimes we also use something more neutral regarding our interview.
I guess I would also add, like for example, when I started at Google, I wasn't actually on a machine learning team, and I basically kind of switched over just by talking to a different manager. So it is possible, depending on how the company works, or what the roles are, to kind of get your feet wet in one area and then kind of shift over and learn the machine learning as you go. So you could avoid the interviews, I guess is my point.
Gotcha. Alrighty. Well, I think that is all of the questions that people have in the chat. What we usually do at this point is demos. It's kind of pretty late, so I don't know if people are still have the stamina to do that. But if anybody wants a demo, we can do that. While I wait for people to answer that question, I have a final question for you guys. So if anybody wants a demo, just ping in the chat and we'll do that right after this. But I have a final question for the three of you guys, which is kind of on costs, which is when you are thinking about models and whatnot, like to what extent does cost matter into the decision making as part of the business? Are some models going to be like, hey, we can't run, like the frequency at which we can train this is limited because of cost? And can you guys talk about that a little bit? Last question, and then we'll go to demos.
Yeah, sure. I can talk briefly about it. So I think for traditional models like logistic regression, you can run most of them in a CPU. And there are open libraries out there like for sklearn, where it provides you with the CPU implementation, and the inference time is also like super fast for some of these implementations. So I think the first thing to note is that what kind of hardware you're going to go for. With traditional approaches, you can do it in a CPU, and so it's a lot cheaper. You can just provision a AWS instance that's generic, and the cost is actually like a few tens to $100 per month per instance. So it's not that expensive. But the trade-off is that for some of these traditional approaches, you cannot do gradient descent training. So what that means is that as you add more data, you'd have to retrain from scratch every single time. So your training actually increases as you add more and more data into your system. So I think that's one thing to note, is that your training time increases, but your inference time is fast, and your hardware is also pretty cheap. But once you're talking about neural network-based models, then the GPU cost comes in. And with the GPU cost, what happens is that you're talking about thousands of dollars per month for inference time serving. The training time also, you would have to provision a GPU. However, the training time is a lot faster because you can basically upload your pre-trained available data. So it's sort of like just gradient descent training. So it's a lot faster. And so it's a trade-off between inference time as well as training time, and the hardware as well. In general, neural networks models are way more expensive than traditional, but I think some of these costs you would have to really specify to your manager, because when we made the transition from traditional models to neural network models, the cost was high, but we didn't know that you could actually save on training time. So that training time saving cost actually helped sell our transition to neural-based models. So it's a trade-off. It's not exactly that neural networks are way more expensive than traditional models. You gain some and you lose some in the process.
Gotcha. I didn't realize that you could actually basically pay for speeding up the time it takes to get a result. That's actually a very cool dimension to it that I hadn't thought about.
Right.
Awesome. Okay. Well, with that, unless Sean or Min, I actually don't know where Min is physically. I know Sean can't see him virtually, but unless they have anything else to add, let's actually go to Andrew to do a demo. And then at the very end, if anyone has any last questions, we can do that. But that'll wrap things up for this Thursday, and we can kind of hang out after the recording is over. But Andrew, whenever you're ready, take it over.
Cool. All right, can you guys see my screen?
Yes.
Which screen?
It says it's your local host 3000 right now.
Okay, cool. Yeah, so I'm working on an application that lets you create custom notifications for your bank account. So I'll just give you a quick run through. Yeah, so I guess I'll just walk through as if I'm creating a new account. So these two tabs are kind of really rough right now, but essentially what you first do is you enter your bank credentials through here. And then once you have that entered, you can go here and the alerts page and then create a new alert. So you first select your account, just choose that, and then you can choose which categories to watch, I guess. But you can also choose the name or just choose to watch all transactions. But for this example, let's just say I have a spending problem on, let's say, fast food. Where is it? And like coffee or something. I can find it. Yeah, all right. And then you select the condition as well as the threshold. So let's put 120. And then after that, you enter your contact information. I haven't actually implemented, or I don't support text and email yet, but let's just say, we'll just add I'm not gonna actually use this as an example, but this is just some like placeholder. And then once you save that, you can see how much you spent so far and stuff like that. And then to demonstrate the actual notifications, the way it's supposed to work is Plaid will send me a webhook whenever new transactions are available to pull. But because I'm working in the sandbox environment, I don't really have control over whether or not I can't like create new transactions. So to demonstrate it, I'm just going to delete one of the transactions from the database. Then let's change this threshold to $1. All right, and then I'm going to go to Postman and then manually trigger a webhook, which will then tell my backend to pull from Plaid again. And then refresh this. You can see that now it's exceeded the threshold, and then yeah, so what Plaid gives you is a list of categories, and each category has like a hierarchy associated. So like this category is overdraft, but it's like a child of bank fees. Wait, what was the question?
Just
I use regex to check through transactions for categories. No. So I'm just matching based on I think the category ID and checking if they're the same.
So Plaid gives you a list of categories, and then on each transaction, you can just to see if the categories are the same.
Yeah.
Mm-hmm. Gotcha. Sweet. And then we have a question from Kenny, which is this built in React, or what framework? What's the tech stack?
Sure. Yeah. So the front end is built with React, and then for the back end, I'm using Go and Firebase Auth and Firestore.
Very cool.
Yep.
Sweet. All right. Any other kind of questions or things for Andrew? Otherwise, dude, this is looking sick. I remember he just pinged me about, oh, this is a good idea. I was like, yeah, dude, this is relatively well scoped. And
yeah,
it's crazy to see this live because it kind of went dark for a little bit, at least from my perspective. It's like, oh, where's Andrew? And then boom.
Yeah. Actually, I was distracted for a good amount of time, end of June and early July, but now that it's ending, I got to get my stuff together.
Hey, there we go. Yeah,
Yeah.
no, this is super exciting. Thank you for the demo. This is really sick, and hopefully we can see this maybe live at some point. We can try it out. That'd be awesome. But
Yeah. I don't have to worry. Yeah, I gotta figure out the security stuff. But yeah.
Sweet.
I don't know how long that'll take, but
yeah, and you should
soon.
sync up with Vijay. Vijay is very much a financial, he thinks a lot about these kind of things, and so you might have a first customer. And just don't steal his information.
Yeah.
So thank you very much, Andrew. A little round of applause to kind of to wrap that up. Does anybody else want to do a demo? I guess it's kind of pushing about the end of where I wanted to go for today's group, but we can still hang on if people want to. But I think other than that, we'll just I'll stop the recording. We can do a little like last goodbyes and maybe ask a question or so, but then that'll be that.
Yeah, I have to drop off right now, but good to see you guys. Good luck on your journey. I know that 2020 has been an interesting year for you all, say the least. But I think that we will get through this, with some help from AI. I hope.
Absolutely.
Yeah,
Thank you, Min, for swinging by. I don't know where Sean and Vijay are. Sean might be facing technical difficulties.
I am here. But yeah, nice presentation. That's a pretty cool feature. Yeah, good luck, everyone. Hopefully we don't need it.
All right.
Yeah.
I'm gonna stop the recording now, and then I guess we're just gonna sign off. All right.